Hi everyone, welcome to week 7 part 2. Structures. In C++, structure is when C++ construct that allows multiple variables to be grouped together. What you see on the slide is the general format of struct. So you have the struct keyword followed by the struct name, and then inside the brackets you have the definition of your field and their types. So here you have the struct name and the field data type definitions. An example of struct declaration: to declare a structure you must have semicolon at the end after the closing brackets. So struct names commonly begin with uppercase letters, as you can see here. The student, you have struct student starts with the uppercase S. And multiple fields of the same type can be in common separated list. So you have string name and address. So instead of having like string name, then string semicolon, then string address semicolon, you can define them both in one list separated by comments, like string name, comma, address. How to define struct variables? To define struct variables, the struct declaration does not allocate memory or create variables. So to define the variables, you use a structure tag as type name, and here you can see the student bill structures, how it's defined, the variable bill, how it's defined. Accessing structure members. To access structure members, you use the dot operator to refer to members of struct variables. So here we have the struct stu1, and the member of the struct is student ID, and you see how it's separated by the dot. You can also have like another members such as student name, so that would be used as stu1 dot name or student name, or the GPA will be stu.gpa. And these member variables can be used in a manner appropriate for their data type. This is a very good programming example that demonstrates the use of structure. So here you have struct payroll, and notice the directives that are used on top: the iStream, the string, dioman, and we are using the namespace std as well. And then notice the variables of the struct, or the members of the struct. You have employee number, you have name, hours, pay rate, and gross pay. And in the main program we defined an employee, which is of a payroll structure, and here we get in the employee number, and was noticed how the employee number of the structure was being called by using the dot, as we mentioned before, and also the employee name. So if we go to the next slide, we can see the program output. So in this case, like if you noticed how each of the members were just printed out by using the cout and the cn to get the data for each of the member variables of the struct. It's very simple and straightforward example. Some operations that you can do on the struct, or you can do with the struct variables. You can display struct variable. You can compare them. You can initialize a structure. So let's go over each one of these operations. To display a struct variable, basically to display the contents of struct variable, you must display each field separately using the dot operator, as we mentioned before. So in this case, if you have cout bill, that doesn't work because you are not saying what variable or a member of the structure bill you need to print out. In order to fix that, you have to use the dot operator by saying you want the student name, the years in school, or the GPA, and notice how everything has to end with a semicolon. So that's how you display the struct variable. How to compare struct variable. Basically, you cannot compare struct variables directly. So if you say if Bill equal William, that won't work. Again, you have to use the dot operator. So instead of using if Bill equal William, you have to say if Bill dot student ID equal William dot student ID, then do this. Otherwise, do that. So that's how we compare the structures. How to initialize structure. Struct variables can be initialized when defined. So in this case, if we have the student s, and these are the values of student s variable member variables. So you have their ID, their name, their year in school, and their GPA. You can also initialize it by member by member after definition. So after you define the struct student, you say s.name equal John, s.gpa is equal to 3.7, s.year in school is equal to 2, and s.student ID equal to 11465. So you may also initialize only some members. So if you don't want to initialize them all within the same group, you can also initialize them well, some members at a time. Like instead of including the student ID, the name, years in school, and GPA, you can only include the student ID. And you cannot skip over members. So student as if you want to do like the ID, the name, and then the jump over to GPA, that won't work and it's illegal, it won't be accepted. And also another characteristics of initializing structures, you cannot initialize in the structure declaration since this does not allocate memory. So after you initialize the after you declare the structure, you go to the initializations. You cannot combine both within the same statement. This is another great programming example that demonstrates the use of structures and how we initialize it. So like we said, we have struct employee pay, and you define the members of the structure, and below on lines 19 and 20 you see how we initialize the structures. And we have two structures here of type employee pay, employee 1, employee 2. Employee 1, we have the name, imagine that would be the employee number, and the pay rate. So for employee 1 we're only getting these three variables, but for employee 2 we're getting the name, employee number, and gross pay as well. So though both we're getting the same variables that we need. So with structures, what you can have with structures, when we talk about arrays of structures, we mean that Structures can be defined in arrays. It can be used in place of parallel arrays. So if you have a const int num student equal 20 in student stu list with passing the num students, so individual structures accessible using subscript notation. Fields within a structure accessible using the dot notation. And then a structure can contain another structure as a member. So if you have a struct person name and you have string name, address city, and struct student, and you have student ID, personal information, years in school, and GPA. So you can have structures within another structure as a member of that structures. So members of nested structures, you use the dot operator multiple times to refer to fields of nested structures. So if you have structure within structure, like in this case, s dot p data dot name equal Joanne. So we use the dot twice to refer to structures within structures. And when you have structures as a function arguments, you may pass members of struct variable to functions. So if you have compute GPA stu.gpa, or you may pass the entire struct variables to a function. So you can pass the members just to one particular variable, or the whole struct by, like, instead of using show GPA is student.gpa, or show data where you want to show everything in a structure, you can call the whole structures. You can use reference parameters of function needs to modify contents of structure variables. Using variable parameters for structures can slow down a program and waste space. So you have to pay attention to that. And using a reference parameter will speed up program, but function may change data into the structure. However, using a const reference parameter allows read-only access to reference parameter. It does not waste space or speed. Returning a structure from a function. Function can return a struct. So if you have student, get student data, that's prototype, and then the call to that would be stu equal get student data. Function must define the local structure for internal use, for use with the return statement. This example on slide 10 shows you how to use a function to return a structure. So you got your student structure temp stu, and notice at the end how it has been returned with using the return statement. Another interesting topic when we talk about structures is pointers. Pointers to structures. Structure variable has an address. Pointer to structures, basically they are variables that can hold the address of a structure. So for example, if you have a student pointer, stu pointer ptr can use m operator to assign address. A structure pointer can be a function parameter, and to access structure member via pointer variable, you must use the open and close parentheses to the reference pointer variable, not field within structure. So you have cout the two open brackets and the pointer name, and then use the dot to call the student ID member. You can use the structure pointer operator to eliminate the use of the parentheses and use clearer notation. So you use the pointer operator instead of the parentheses, and so the statement cout will be using the pointer without the parentheses.